talk about is the graph. There's a relationship or connection between the graphs of functions and their derivatives. And we're going to use Wolfram to talk about this. So let me quickly open Wolfram. Cool. Does everyone see Wolfram now? Okay, awesome. Okay, so I'm going to start with a function. Our function is going to be f of x equals, let's see, which one should we do? Let's do x squared minus 2x. Now, instead of calculating the derivative by hand, I want to show you that Wolfram can calculate it for you. So what's the notation that we've learned for how you write the derivative? If you have your function f, what's the notation for its derivative? Yeah, or f prime, right? So if you just type in f prime x, Wolfram gives you the derivative. So apparently, what is the derivative of x squared minus 2x? It is 2x minus 2. Let's just put traditional form. So the derivative of x squared minus 2x apparently is 2x minus 2. Boom. We could have calculated that with a limit, but let's just not bother with that right now because I don't want to spend a bunch of time having to do that. Is everyone on board with I had Wolfram calculate it for us so that we didn't have to go through the long limit calculation, but that's the only way you know how to do right now. I just don't want to because that would just take 10 minutes or 5 to 10 minutes. Okay. Does everyone see how you can use Wolfram to actually calculate derivatives for you to check your answers? This is super important. It will help you speed up the process of doing things. Okay, so now what we're going to do is we're going to look at their graphs together. So let's plot, and let's plot just the function f of x first. And let's go from x, let's go from -1 to +3. Okay, does everyone see the x squared minus 2x graph? Hopefully you look at this and you're like, oh yeah, that's more or less what I expected to see. So now we're gonna also put in the graph of f prime of x, the derivative. There's your 2x minus 2. Okay, now I want to point something out to you. I'm going to do this I'm going to sort of show you what's happening. I want to annotate this. Okay, I'm just going to share the screen, and then we're going to annotate it. Okay, cool. There we go. Okay, so let's annotate. Okay, so I want to point out the vertex of this parabola is at x equals 1. So I'm going to draw a red line through it at x equals 1 right here. So there's x equals 1. To the left of x equals 1, how would you describe what the function is doing and how it's different from what's happening to the right of x equals 1? There's two different things happening to the left of the vertex compared to the right of the vertex. What is the difference? So if you look at the vertex right here at 1, -1. Okay, cool. Yeah. So on the left, no, they're doing the same thing. If you look at to the left of the vertex versus to the right of the vertex, they're both going to positive infinity because they go up like this. But you always read the graphs from left to right. So I'm just gonna put in some dots for what's happening. If you look as I'm going from left to right, what's happening to these y values? Yeah, they're decreasing. And they keep decreasing until I get to the vertex. And then what happens after I get to the vertex? What happens to the y values? Yeah, thank you. So to the left of the vertex, my original function f of x is decreasing. To the right of the vertex, my original f of x function is increasing. Now I want you to turn your attention to the derivative, which is this line, f prime x equals 2x minus 2. What is the value of the derivative at the vertex? Like where x equals 1. So if you look at the y value of that line at x equals 1, where the vertex is, what is the y value of the line? No, it's not -1. That's the value of the vertex is -1. The value of the derivative at 1 is 0. And now this is the interesting thing. On the right side of the graph, where the function is increasing, all of those y values are positive. And if you look at the y values on the left side of the graph, where the function is decreasing, all of those y values are negative. And this is not a coincidence. There's a relationship between the graph of the derivative and the graph of the original function, which we're going to explore more later, but it has to do with when the original function is increasing, the derivative is positive. And when the original function is decreasing, the derivative is negative. And you can see that because the derivative function ends up being 0 at the point where it switches from decreasing to increasing. It switches from negative to positive. And I'll do another example. Here, someone throw out a function. This will be our new g of x. Like some sort of polynomial. Give us a function. (18x plus 5). Cool. Okay, let's graph that. And we're going to graph it from -5 to 5. Actually, let's graph it from -3 to 4. -4 to 4. There we go. Okay, cool. So this function, as you go from left to right, what is it always doing? As you're going from left to right, what's happening to the y? It's always increasing, which means when we graph its derivative, let's see what happens. Oh my god, look. The derivative is always a positive number. Why? Because the original function is always increasing. Here, how would you make this function always decreasing? Minus 18x, or sorry, 18x plus 5 is always increasing. How would you make the line always decreasing? Yeah, minus 18. So let's re-graph everything. You see how the graph is always decreasing? And if you look at the function, the derivative, it's negative. We could put it in a square here. Okay, so if you look at the function, oops. Sorry. If you look at the function, Jesus, what the sorry. There we go. The vertex is like right here. Do you see how it's increasing up to that line? And if you look at it's increasing up to the vertex right there. If you look at the line, do you see how it's positive above the x-axis? And then what happens once you go past x equals 0? It starts decreasing, and then it's under the x-axis, it's negative. So there's this interesting connection between the two of them. If your original function, this parabola, is increasing, it's going up, your derivative has positive values. But then if your original function is decreasing, it's going down, your original function has negative values. Okay. So I just wanted to show you that. We're going to talk more about it in the